Good afternoon, Algebra 2 students. So we are looking at a bell ringer here. Today we're going through congruent and similar figures and Pythagorean's theorem, so it shouldn't be too bad. And this says quiz review. There's no quiz today, but I plan on having some practice quizzes when I come back. Alright, so just look at these here. We'll see if we can figure them out. So we want to state domain and range of each relation, or write whether or not it's a function. Okay, write yes or no for if it's a function. So domain is just the x values. Range is simply the y values. And we're just going to write them out from least to greatest. So we're looking at all the x's. We only write each number one time from least to greatest. So the smallest number is a 0, and then we have a 4, a 5, and a 7. Okay, that's our domain. For our range, we have, so we're looking at the y values here. We're looking at those y's. So -2 is the smallest. -1 is next in line. And then we have a 5, a 9, and a 12. Okay, and we put them in curly brackets. I know mine don't look the best on here, but we put those in curly brackets to denote that those numbers are in a set. Okay, so we have 0, 4, 5, 7 for the x values, -2, -1, 5, 9, 12 for the y values. So that should kind of lead us into this one. This is a different question, but we're doing x values for domain, y values for the range. So domain, we can just kind of look at what points line up with these x values here. And we don't write them out twice. Remember, we only write it out one time. So we have a -4, and -2, a 1, and then a 2. Those are my x values. Y values, we're going this way. We're looking at the y's here. So the smallest y value is the -3, and then we have a -1, and then we have a 1, 2, and a 3. Those are my domains and ranges, okay? Factoring is the next thing we're looking at. So this was on your assignment. And if we had some questions on factoring, that's fine. We can take care of them when I come back. But just to kind of show you how some of these work, these are some of the harder ones. So number 3, we start out by giving ourselves 2 sets of parentheses because we're pretty much undoing this so it looks like FOIL. Okay? And then we ask ourselves, what 2 numbers can I put in the front of my parentheses to FOIL out and get a 4x squared? When it's a perfect square like this, I have a perfect square here and perfect square here, it's usually going to be 2 and 2 rather than 4 and 1. The other option we could have is a 4 and a 1, but we're going to go 2x and 2x, and then we have 2 variables. So when we have 2 variables, you just put another variable in the back end. It works the same exact way. We're just putting a variable back there. Okay, and that would just be a 1 and a 1. Okay, to check these, remember this is smile method, so we check out here. So that 2xy, check this 2xy, and these numbers need to either add or subtract to get me that middle 4xy, which they add to get me 4xy, and that's what I wanted to add to get that. Okay, so let's get rid of those and put our pluses in there, and we're good. So that's number 3 right here. Okay, number 4 we'll do right below there. So again, this is the perfect square, so we're probably going to split that to 2 and 2. And then this is the perfect square, so we can split that to 4 and 4. But I just caught something that we probably should have done to begin with. All right, I don't want to do it this way. We could, but we're going to have to take more out in the end. Everything up here is divisible by 4. So we want to take a 4 out first, and then we start factoring. So if we take a 4 out, we have a squared plus 4ab plus 4b squared. And now we look at factoring this. So you say, what 2 numbers multiply to 4 and add to 4? That's a 2 and a 2. So we're going to have an a in the front, 2b in the back. And that 4 stays in front there. So everything's positive here, so these should all be positive. And that's how we do that one. All right. And then we're going to take care of these down here, write expressions for numbers. So 6 less than a number. So we're taking 6 from a number, so that's x minus 6. This is one that people always kind of flip around. They want to just do 6 minus x because they're reading it from left to right, and that's the way their brain's processing it. We're doing 6 out of that number, okay? And this one is 2 more than a number, so this will just be x plus 2, okay? So, jumping into the lesson, we're looking at congruent and similar figures. Hopefully you remember those from geometry and Pythagorean theorem. We do a little bit of geometry in this class, but not much, okay? These will come back, and they kind of hit geometry in the beginning and the end of this class. So, starting out with congruent figures, okay? So you have an area where you can write down the definition of congruent. These figures have the same size and the same shape. Everything is the same. It's all equivalent, okay? And when you're looking at two shapes, so like this little hash mark and this little hash mark, that means those two sides are the same. Same thing kind of goes with angles. So angle B is equivalent to angle F, okay? Or congruent to angle F. They are the same size and same shape. When we're looking at similarity, similar figures have the same size, or excuse me, same shape, but not necessarily the same size, okay? So they have the same shape, they look about the same, but they don't have the same size. So I say that objects look scaled, kind of like a blueprint versus an actual house. The blueprint is a scaled version of the house, okay? So what we can do with similar shapes is we can make proportionalities here. We can write out fractions to show that they are proportional. So I would do 2 to 4, 3 to 6, and 4 to 8. So those are all equivalent fractions. So this is the half, this is the half, this is the half. Okay? If we can do that and everything checks out, then they're similar shapes. So let's try to solve some proportions, because we're going to have to be able to do this to figure out similar shapes or to solve for certain sides. So in Algebra 2, we do this with cross multiplication. You may have learned fish method or butterfly method or something like that in previous classes, but we are doing cross multiplication. So we cross multiply here. So 36 times 10, 360. And then we go the other way. 45 times c, 45c. And then this is the basic equation that we're just solving. So we do 360 divided by 45. Okay, and when we do that, you can use a calculator for that if you need to. You get c equals 8. Okay, so that works out nice. So let's do this one. So 12 times 3, 12, 24, 36. 7 times x, 7x. And we divide those out. 36 sevenths, and that doesn't work out nice, so we can leave that as 36 sevenths, or you can write it as a decimal, which is about 5.1. Okay. Then we're going to use proportionalities for solving stuff like this. So Mel fills his gas tank with 6 gallons of premium unleaded fuel for $18.68. How much would it cost him to fill an 18-gallon tank? Now, what I would do is I would just figure out the cost per gallon, and then I would take that times 18. All right. Since we're using proportions here, we're going to set it up. We got 6 gallons for $18.68. We have 18 gallons for X dollars that we don't know. And then we solve this just like we did on the last ones. So cross multiply 6x, 18 times 1868 is 336.24, and then we just divide both sides by 6, and we get x equals 56.04. So $56.04 for that 18-gallon tank. All right. Like I said, you could do this any way you want to. This is the answer we have to arrive at, 56.04. Okay. So if we're looking at two shapes, we have to figure out if they're similar or not. And we're going to use that to solve our triangle. So we're looking at these. we kind of look at this one to this one and say, all right, well, 6 to 18, well, that's times 3. Okay, so my similarity, my scale factor from little to big is times 3. Let's see if that works here again. So 8 times 3 is 24. Yeah, that checks out. Okay, so now if we're going little to big, something times 3 is 21. Or we do it backwards, we say 21 divided by 3, and that's going to get us to a 7. Okay, this should be pretty standard. You guys should know how to do this stuff, but we're just kind of review it here quick. So this is a 7 meters here. I want to put that label with it. All right, so let's look at another one here. So we have kind of a word problem set up here. City of Manfields plans to build a bridge across Pine Lake. Use the information in the diagram at the right to find the distance across Pine Lake. Why these people want to build a bridge across the lake that way, I don't know. Maybe they want something good for wedding pictures or something. Who knows? We got to figure it out though. Okay, so we have our little triangle, that's 155, and our big triangle, which is x down here. I don't know that. And you might think 120. However, the big triangle is this whole length, which is those two together. So that's 220. So we have to do a proportion to set this up. So let's do little triangle to big triangle. So whenever you're setting up your proportions, if you're doing little to big for one proportion, you have to do little to big for the second one. It has to be consistent, otherwise it will be incorrect. So my little one is 55. Big one, x, I don't know. Little one is 100. Big one is the whole thing, 220. And now we're ready to go. So 55 times 220, that's 12,100. And then we got 100x. We got to divide both sides by 100, and we should get our answer. Cancel out the zeros. So we get x equals 121. So we should have 121 meters from here to here. So that's a pretty good sized bridge. All right. So with these ones, pause the video here quick and look at these and just figure out if they're similar or not. All right. So sometimes with the shapes, you have to kind of make sure that they're oriented correctly when you're thinking about them. See how this one is oriented differently than that one, but we are given an angle there, so you're going to line those angles up. All right, so we kind of go around for each one. So looking at this one to this one, it looks like we have a scale factor of times 2 to get from little to big. So what I would do is go around to each corresponding side, times 2, yep, times 2, yep, times 2, and we're good. So these are similar. So just look at every single one of the sides and see if we have the same scale factor. So this one is a little bit harder to figure out how to go from one to the other. If you're going just from left to right like I did, I would figure out how many times 3 goes into 1.8 or vice versa. It might just be easier to divide these. So 3 divided by 1.8 is about 1.67. So I'm going to see if I do 7.2 divided by 5.4, if I get the same thing. Which it looks like we get about 1.3. So 7.2 divided by 5.4 is about 1.3 repeating. So these are not the same thing. So that means these are not similar, because we have to have the same scale factor, so we have to have the same proportion. This proportion is not equal to that proportion, so they are not similar. Okay, so we got another question down here that's kind of tricky. So I want you guys to pause the video here, work through this and see if you can figure out x. I want you to show the proportions and show the steps to show how you got that, and then play the video again. All right, so coming back to this, we have little triangle here, a 3, and a big triangle, 6. And remember, little triangle here would be x, big triangle, so that's a little bit trickier, would be x plus 4. Okay, so we got to set up our proportion. Let's do the 3 to the 6. So that's my little triangle here to my big triangle here. And then we have x for the little triangle side length there, and then x plus 4 for the whole thing. So your butterfly method or your fish method does not work here, because when we cross multiply, we're going to have to distribute. So that's why we make sure we practice cross multiplication in Algebra 2. So 3x plus 12, let's fix that up there. So 12 equals 6x. Okay, we haven't done a whole lot of this yet. This is just basic solving equations here, all right? So when you're solving equations, you want to put the x on one side, so it looks like we're going to move this over. And we have to do the opposite of that to move it from one side to another. So that's going to cancel. And then we get 12 equals 3x. So see how we did the same thing on the left as we did the right? So that's how we maintain balance in the equation. Okay? Equations have to be balanced the whole time. You can't just take a piece out of it. So then from here, we're dividing out that 3. And again, we're doing the same thing to the left and the right. We keep things balanced. So we get x equals 4. So 12 divided by 3 is a 4. Okay? So we got that right there is 4. Maybe a quicker way that you could have done it, you said, okay, so 3 to here, 6 to here, so my scale factor is 2. It looks like this is about half, okay? Which we could say this is 4. That's got to be 4 because this side length should be 8, okay? That's another way to do it, kind of quicker. But then you'd be assuming that this is a 50-50, which it doesn't really tell us that that's the same as that, okay? So you got to be careful with that stuff sometimes. All right, here right now is a good time to take a break. If you would like to, pause the video here, take a break, and follow these instructions, and then come back. All right, so final thing here for the lesson. We got Pythagorean theorem. So this is what Pythagorean theorem says. So it states that the square of the hypotenuse C is equal to the sum of the squares of the lengths of the legs A and B. If you forgot, it is a squared plus b squared equals c squared. That is Pythagorean's theorem. Okay? That's your formula. That should be something that you know off the top of your head real easy. Okay? So we're going to use this to figure out, so this is essentially what you use to figure out if things are right triangles or not, or to solve side lengths of right triangles. Okay? We got these two right triangles down here. Trying to make it a little easier for you with the nice numbers. So we need to take this one and this one, square them and add them together. And then we get c squared. So 5, and you should use parentheses, but it shouldn't make much of a difference when you're working with shapes. Plus 12 squared equals c squared. So that's 25. That's 144. Hopefully you knew those off the top of your head. So this is a 169 equals c squared. And then we have to undo a square. Okay, this is another algebraic operation. We have to square root both sides, and that'll undo the square. And you get c equals 13. Second guessing myself there, but c equals 13. So this is a 5, 12, 13 triangle. If you remember those from geometry, those are called Pythagorean triples. Okay, there's a handful of them. So let's try B together. So this one's going to be formatted a little bit differently because we're going to have the equals 100 or equals 10 squared off to the right, and we're going to have to solve for x squared. So 6 squared, 36, plus x squared equals 100. Do a little bit of moving around. Move the 36 over. X squared equals 64, and then again undo the square. So x equals square root of 64 is an 8. So that again is another Pythagorean triple, 6, 8, 10. Okay, so you can apply this to any right triangle, but you have to know that it's a right triangle before you can apply it. All right, and I didn't do it down here, I did it up here. Make sure you supply labels with everything. Labels are important when you're working with shapes. Okay, we're going to skip over that last example here. I'm going to write one more example down here. So let's say we're given something that is like this, where we have a 5 and a 7 and a 12. Okay, so let's say we have a triangle with side lengths, that's kind of a fat triangle there. Side lengths 5, 7, and 12. Prove that this is or is not a right triangle. So what you have to do is we take this and we're going to use Pythagorean theorem to see if these all check out. So this would be 25, this is a 49, this is a 144, and plug those into Pythagorean theorem. Does 25 plus 49 equal 144? No, it does not equal that, so this is not a right triangle. Okay, you're going to have some questions like that on your homework where you're asked to prove if something is or is not a right triangle based on 3 numbers. Okay, so you just throw them in Pythagorean theorem. You got leg, leg, hypotenuse, and see if that works, just like that. Okay. So the next ones that we're going to skip over, if you wanted to, you could try them later, but this is where you're using your 30, 60, 90 triangles, where you have your x, and then x root 2. Hopefully you kind of remember those things. Then you have x, and then I think it's x root 3, and then 2. So these are your ratios. We can practice those another day. Okay. One last thing to review here, angle properties. So we got to be able to break down where angles are into transversals. And again, this should be something that's pretty quick for you. Okay. You have these 8 angles you're trying to figure out what they are, and you're only given one angle of 65. So you should be able to figure out angle number 7 because these are a linear pair. Okay, a line is 180 degrees, so I got to figure out what that is. That's just going to be 115 degrees because that is a linear pair. From there, that should trigger off all the other angles. Okay, so these 2 angles are vertical angles, so that's a 65-degree angle. Okay, which we have a 65 here because those are corresponding interior, or those are alternating interior, excuse me. This would be a corresponding, that 65 and that 2. Okay, and this is also going to be a 65. So these are vertical angles, and then the same thing, these are alternating, or vertical angles here. And then that is alternating interior, so 115, and another vertical angle here. Or alternating exterior also works. Okay? So hopefully you remembered those angle properties as well. We don't do a whole lot of those, but they pop up on the ACT a lot. Okay? So I took this off of your assignment. So these are the 2 things that you have to do for the lesson. Okay? I have these in Canvas. This is in our textbook. So that's page P23, which is in the front of the textbook. It would be 08 for Pythagorean theorem. Okay? If you have any questions, send me an email and I will do my best to help you out.